alcohols, phenols and ether, one of the most important chapter in second PUC chemistry. Here is a simple revision notes of this chapter, which are most important topics we are going to discuss. Primary alcohol, in the sense alcoholic group linked to the carbon having only one carbon chain. In secondary alcohol, alcoholic group containing carbon has two carbon chain and only one hydrogen. Tertiary alcohol, alcoholic group containing carbon has three carbon chain. So based on that, primary, secondary and tertiary alcohols are there. Second, very important for 2 marks, esterification reaction. It's a reaction between carboxylic acid and alcohol in the presence of concentrated sulfuric acid to give ester and water. This is esterification reaction. For 2 marks they are going to ask. Now come to Lucas reagent. Lucas reagent is the mixture of anhydrous zinc chloride and concentrated HCl, and this reagent is used to differentiate primary, secondary and tertiary alcohol. Now let us see how Lucas reagent help us to differentiate this alcohol. When you add Lucas reagent to the tertiary alcohol, you will get turbidity immediately. Turbidity you will get because of the formation of alkyl halide. When you add Lucas reagent to secondary alcohol, turbidity comes after 5 minutes, and primary alcohol gives turbidity only after heating. So this way Lucas reagent help us to differentiate the alcohol. Now come to a 3 marks very important mechanism of hydration of alkene to alcohol. It's a 3-step mechanism, very important for 3 marks. Let us see step 1. In the step 1, there is a protonation of alkene. Protonation happens and forms carbocation plus release of water. Second step, attack of water to the carbocation. To this carbocation, water will attack and formation of oxonium ion. Third step, from this oxonium ion there is a release of proton to form alcohol. So 3-step mechanism of alkene to alcohol is very important. Then one more is preparation of alcohol from carbonyl compound is also very repeated question. Carbonyl compounds like aldehyde when undergo reduction in the presence of catalyst nickel, it gives primary alcohol. Aldehyde gives primary alcohol, remember. And second carbonyl compound is ketone on reduction gives secondary alcohol. So remember, aldehyde gives primary alcohol and ketone gives secondary alcohol. We have one more mechanism in this chapter. One more 3 marks mechanism of dehydration of ethanol to ethene. This is also very important. First step, for this ethanol there is a protonation, addition of proton to form oxonium ion. In the second step, from this oxonium ion, this is oxonium ion, this water will release and the positive charge shift to the carbon atom. So there is a formation of carbocation. In the last step, from the carbocation there is a release of one proton. From this carbocation there is a release of one hydrogen as proton and there is a conversion of ethene. So this is the mechanism of acid catalyzed dehydration of ethanol to ethene, very important for 3 marks. One more highly important question here is formation of alcohol from carboxylic acid. Carboxylic acid when treats with lithium aluminum hydride, it undergo reduction to produce alcohol, primary alcohol. So about lithium aluminum hydride they'll ask the question. Other important topics of this chapter, the classification of phenol into catechol, resorcinol and quinol, very important. Then one more important point here is preparation of phenol from cumin. Is highly important, most repeated question. This is cumin. It converts to cumin hydroperoxide on treating with oxygen. Then on hydrolysis it gives phenol and acetone. Acetone is a byproduct. One more important reaction here is Reimer-Tiemann reaction, where phenol on treating with chloroform and sodium hydroxide, it gives salicylaldehyde. Highly repeated question this also. Then other important reaction of phenol is esterification of phenol. Benzoic acid and phenol reacts in the presence of sulfuric acid to give one ester called phenyl benzoate. Then one more important 2 marks reaction is phenol with zinc dust. When phenol treats with zinc dust, it gives benzene and zinc oxide. Another important 2 marks equation here is oxidation of phenol. Phenol, when undergo oxidation in the presence of sodium dichromate, it gives benzoquinone. Benzoquinone, very important. And similarly, phenol on treating with concentrated nitric acid, this is also very important reaction. When phenol reacts with concentrated nitric acid, it gives yellow color picric acid, yellow precipitate picric acid, 2 4 6 trinitro. This is nitro group. This is nitro group, 2 4 6 trinitrophenol. When phenol reacts with nitric acid, it gives 2 4 6 trinitrophenol, yellow precipitate. Similarly, we have one more important reaction here is phenol with bromine water. When phenol reacts with bromine water, when reacts with bromine water, it gives a white precipitate of 2 4 6 tribromophenol with the release of HBr, 3HBr. Then in case of ether, remember there are 2 types of ether. Symmetric or simple ether, where across ether bond you can find similar alkyl groups. Mixed or unsymmetric ether, across ether bond you can find dissimilar alkyl groups. So here ether synthesis is highly important for 2 marks, that is Williamson's ether synthesis, where sodium alkoxide and alkyl halide reacts by SN2 mechanism to give ether and sodium halide. There is an example also, please refer, very important. And last highly important reaction is Kolbe's reaction, where phenol on treating with sodium hydroxide and carbon dioxide gives salicylic acid or 2-hydroxybenzoic acid. So these are some of the important reactions of this alcohol, phenols and ether chapter. I hope it is going to be useful to you. Thank you.